Okay, so another kind of problem, which I didn't see I had a problem talking about, but I usually just use this data anyways, is calculating the temperature when spontaneity changes. So you know that there are situations where delta H is positive and delta S is negative, in which if the temperature is high enough, then the free energy will be negative. And if delta H is negative, but delta S is also negative, there are temperatures at which eventually the temperature will create such a situation where this term becomes more important than this term or bigger than this term, and it'll be negative as well. And so one of the things that we talk about is the temperature at which you have to set a system to in order to make it spontaneous. So the way we do that is we look at this equation and we think, well, if delta G was 0, that's the temperature at which spontaneity would change. Delta H minus T delta S is still true, so I can rearrange that delta H is equal to T delta S, or T is equal to delta H over delta S. Now, you know that T, the temperature in Kelvin, always has to be positive. So what that means is this will happen anytime delta H and delta S have the same sign. So if this is positive and this is positive, or if this is negative and this is negative, then you'll get a temperature that makes sense in terms of the Kelvin scale. So for these particular problems, you can look at them and say, oh, well, this one's positive, this one's negative. It's never going to do that. This one's negative and that one's positive. It'll never do that. And this one, which is actually just the same one at two different temperatures, this one I could calculate the temperature at which the reaction becomes spontaneous. Now, remember what we did, which was different in the previous slide, is we just went ahead and calculated whether or not it's spontaneous by plugging the temperature in. But at what temperature did it become non-spontaneous? Oops, sorry, didn't mean to show all that stuff in the background. Anyways, so we're going to go ahead and do the calculation. We'll say T is equal to minus 115 kilojoules per mole. Now I want it to be either in kilojoules or in joules. So what I'm going to do is convert this to joules by saying times 10 to the third joules. And then I'm going to divide it by minus 263 joules per Kelvin, like this. And so the joules will cancel, and then I have an inverse Kelvin on the bottom. So what will happen is this will come out to be units of Kelvin. And the temperature at which that takes place, so 115 change sign times 10 to the third divided by 263 and change sign, and I get 437 degrees Kelvin. So at low temperatures, it's spontaneous because delta H is negative. And then at high temperatures, it becomes non-spontaneous. And the temperature at which it switches from being spontaneous to non-spontaneous is 437 degrees Kelvin, which is why when we did this calculation before and came up with 46.7 kilojoules, right? That's why it was positive, because 615 is above that threshold temperature.